Let's start on example 8. So when I look at this example, I notice that the numbers on the left all have a 2 as the rightmost number on that side, but I do notice that the number 1 increases by 1 each time. So in the first row, there was only a single 1. In the second row, there was 2 1s, 3 1s, and 4 1s. Now when I look on the right-hand side, I notice that the number of 1s also correspond to the maximum number that is shown in this sort of pyramid scheme of numbers. The maximum number is a 2 when there was 2 1s. So the number on the right-hand side starts at a 1, goes up to that maximum number, and then goes back down to 1. When there were 3 1s, I noticed that the number went 1, 2, 3, which is the maximum number of 1s, back down 2 and 1. So that's my observations. I'll just kind of put them in point form notes here. So the number of 1s on the left increased by 1. I also know that the number on the left always ends in a 2. And then I notice that the result, the stuff after the equal sign, is equal to sort of like a pyramid that goes up to the maximum. The max number of that pyramid is the number of 1s that appeared on the left. So for example, this last one had 4 1s, so my number started at 1, it went up to that maximum number, and then went back down to 1. Now in this specific example, sometimes writing a conjecture is a little bit hard, like in words, but maybe you can use examples to illustrate what you're trying to say. So in this example, I said the number of 1s that show up on the left of 2, so that's these numbers I've kind of highlighted here, will dictate the result of the maximum number on the right, which I'm referring to that number there. The number on the right will start at 1, go up consecutively, like in order, until the maximum number, and then descend back down to 1. So it goes 1, 2, 3, 4 was my maximum number, and then it went back down 3, 2, 1. Okay, so that's my conjecture, and then I tried to kind of highlight what I mean by that. So I said if there was 5 1s, then the result would be 5 1s and a 2 on the left, which is equal to 1, 2, 3, 4, 5 is my maximum number, back down 4, 3, 2, 1. When we look at example 9, we created a circle. It has n points, so n can be any number. Right now we're referring to kind of 1, 2, 3, so kind of like our whole numbers. So on the first circle, I have 1 point on the circumference or the edge of the circle. In the second example, I have 2 points on the edge of the circle or the circumference, 3, 4, and 5, and so on. This would continue on. Now we want to write a conjecture for the number of sections or regions formed by creating this points on the circumference of the circle. So in this example, I had 1 section formed. In this example, I had 2 sections formed. In the third example, I have 4 sections formed. So I'm going to start writing that down. I had 1 section, 2 section, and these are the number of sections. Then I had 4. And now in my observations, I'm going to kind of keep going and trying to observe how many regions I notice here. So 1, 2, 3, 4, 5, 6, 7, 8 regions. When I calculate how many regions are being formed on the right-hand side here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 regions are formed. So if I'm trying to create a conjecture here, I need to figure out what is happening between these numbers. I notice that 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I'm observing that the numbers 1 to 2, 2 to 4, 4 to 8, the numbers are doubling. So when I write my conjecture, so I would say when a circle has n points marked on the circumference, the number of regions formed the number of regions formed doubles each time. And that's what we have for conjectures. Again, in the lessons to come, we're going to actually try to determine whether these conjectures are true or false.